Now, for redox equations, um, this word redox is actually a combination of two words. Those two words are reduction, and the other word is going to be oxidation. Now, when we're talking about these two words, it's important to note that each of them are responsible for two separate processes. And when I talk about reduction and oxidation, um, I'm reminded of this concept of Leo goes Gur. So I'm going to go ahead and write that down right here. Leo, excuse my, penmanship. And we'll put goes, and we'll put Gur. And it highlights this principle of kind of a lion when you're talking about Leo. Now, my drawing, I'm not its true artist, so if it's not great, I apologize. My specialty is mostly in chemistry, and so that's supposed to be more or less my picture of a lion. And the lion here, represented by Leo goes Gur, is the mnemonic that helps us remember oxidation and reduction. Now, the L stands for loses. The E stands for electrons, and the O stands for oxidation. And for this guy, the Gur part, G stands for gaining, E stands for electrons, and R stands for reduction. And so when you're thinking about reduction, there's a couple of things that's going to happen. When you're talking about oxidation, the same kind of things are going to be considered. So for instance, I'm going to go ahead and start with a neutral element. We have a neutral element represented here. That element is sodium. It has the same number of electrons and the same number of protons. But sodium has a tendency of forming something called a cation. It will form a cation. Now, when it forms this cation, this means that it has lost its electrons. And now you have that process of that electron being represented. Now, this defines losing electrons. And when you lose electrons, that is going to be oxidation. Now, what you should notice when you're talking about this process of oxidation is that Na goes from having basically a zero in its subscript. That's understood to be a zero if you're comparing this to this. Zero in its not subscript, excuse me, superscript. And this becomes sodium with a plus here, which stands for +1. And I'll put the 1 in there just so we're on the same page. And what's interesting is that the superscript increases for oxidation. So you want to remember a few things when you're talking about oxidation. It loses its electron. The superscript increases in oxidation. And all of these will define oxidation. Now, if we want to take a look at reduction, This guy is sulfur, neutral sulfur. It will become this, but it must get the aid of this. So that 2e is going to represent my two electrons. I'm going to go ahead and put a line to separate those. It gets the two electrons. Those kind of fuse together, if you will. It takes on those electrons and becomes sulfide ion. Sulfide ion. And now let me go ahead and, while I'm at it, write these names for these ions. Sodium ion. That's this guy here. This is sulfide ion. So now that we have the names for that, we can also describe what's happening. This is gaining electrons. Therefore, it is reduction, as I mentioned. And let's look at S before and after. This is understood to be kind of a neutral version of S. That's 0. And then when it goes through that process, the number becomes -2. Now, if you notice the trend here, for oxidation, this number increases, but here, that superscript, the superscript is just the number up top, decreases. And the decreases for reduction. And so part of the trend when you're looking at identifying an element and its tendency or behavior is in which side of it is located on the periodic table, also looking at what it's doing as a process of its charge. If that number is increasing, it's going to be oxidation. If this number is decreasing, it's going to be reduction. Now, you might not look at an element and see 0 automatically, but if that S is located by itself, rest assured, we believe it has kind of what's evidence is 0. And if we were talking about something like oxidation numbers, that actually would have an oxidation number of 0. But for all intents and purposes, you just want to understand that this went from having basically no charge to having a -2 charge, which means that it gained 2 electrons in that process. And this one, it lost an electron to become sodium and iron. And you want to be familiar with your periodic table in order to label that process. And so those are two ways of looking at it. Just looking at it in its neutral state compared to its charged state, and having a general idea of where it's located on the periodic table.